Some of the various materials used in these labs consist of, first and foremost, this slider used to transport both lenses, this divider here used to split light, screens used to capture light, and this cardboard divider used to hold lenses in place as light entered through them. In this way, the screen can then filter light through them effectively to produce viable results where the screen would normally land.
For exploration 1, we use lens 1, which is a double convex mirror. This mirror is bent outwards. Now, the image appears to be enlarged when kept at the midpoint of the eye in the picture. However, it is much clearer that when the lens is moved closer into proximity to the beetle, it also appears to grow in size. Turning the lens over makes no real impact over the focus and size of the image.
One lens 2, the image appears to be clear and it grew slightly when placed under the second lens. No matter how far the distance or how close it was to our eyes, it stayed the same size and focus. Flipping the lens made no effect whatsoever and the beetle stayed the same.
Lens 3 was a double concave lens. The beetle appeared to shrink to a smaller size, much smaller than the other two lenses. The distance made no impact on the focus or enlargement of the image whatsoever, so flipping the lens also provides no change to the picture.
When exploring refraction, we can see that in exploration 2, using the coin, when we submerge the coin into water, it appears to be of a much larger diameter, and its thickness has increased. The focus is obviously more clear, thus surpassing even the dry version. For exploration 2, including the pencil, we simply submerge it in 2/3 of water, and you can see that even though the object is partially submerged in water, you can still see the effects of refraction.
Due to the height of this candle flame, light entering the slots in this metal plate under the cardboard sheet enter going down at an angle and are as of yet unrefracted. Although it is not clearly seen, the light, when exposed to lens 1, the light rays coming through the slot appear to come together and converge at what we call a focal point.
For exploration 3, the light appears to be unaffected by the introduction of lens 2. Although the focal point cannot be seen clearly, further inspection reveals that the area of convergence is much farther than the previous lens.
As we can see here, when light rays enter through lens 3, which is a double concave lens, it refracts them in a manner that splits them apart and does not create a focal point whatsoever on this cardboard slab.
Lens 2, only the shadow of the lens was visible, so only a small circular spot of light that could be seen in the image appears in the middle. So it never comes really into focus no matter how far you move the screen or how closer you move the screen to the flame.
The purpose of this experiment was to see how light that is refracted impacts the images that enter our eyes. And to do so, we use 3 lenses. The first one is a double convex lens, the second as a single convex lens, and a third as a double concave lens. All 3 of these acted as refractors to subject images to various states of distortion through light.
Our experiments, something that might have affected the way our experiments were shaped out was the height of the candle. The height of the candle affected the way the rays of light went into our lens.
Size or the type of lens that we use, its shape, affects the image we see. For example, we would see either a smaller image, a larger image, or an inverted image. And how we worked, well, what we would do was that we would do the experiments, and then afterwards, we would take data as in take videos or reflection video.
My favorite part of the experiment from Lens Week was when we got to work with the candles. With the when we light them, we were able to see the reflection through the lenses and see the distance of them, like the more far the lens was from the candle, like the show the reflection was from the lens.